Hello everyone, welcome to the SQRT channel. In this video, we are going to take a problem from 2003 China mathematical competition. Here we have an expression that we need to find its maximum. The expression itself is tan of x plus 2 pi over 3 minus tan of x plus pi over 6 plus cosine of x plus pi over 6. X is going to be between negative 5 pi over 12 and negative pi over 3. Now, before moving forward to talk about the solution, as usual, make sure that you pause the video to think about this problem, and we will see you in about 15 seconds. To solve this problem, let's start with doing a few things here. When we look at the three terms that we have here, one of them is x plus 2 pi over 3. The other two are x plus pi over 6. So basically, the first thing that I'm going to do is to understand what I'm going to do with these variables here. I'm going to start with using a new variable instead of just using x plus pi over 6. First of all, x belongs to negative 5 pi over 12 and negative pi over 3. In that case, since I have this negative tan of x plus pi over 6, I'm going to move negative inside tan, and then we will have negative x minus pi over 6. Because of that, I'm going to start with defining a new variable as negative x minus pi over 6. Remember, cosine of x plus pi over 6 and cosine of negative x negative pi over 6 are going to be equal. So I'm going to be safe here. Now x belongs to the range that you are seeing here. Negative x is going to belong to pi over 3 and 5 pi over 12. Note that I swap the lower bound and upper bound of this range since I multiply both sides by a negative 1 here. Now I'm going to subtract another pi over 6, and then you are going to end up with a range that you see here. It's between pi over 6 and pi over 4. Altogether, I defined a new variable as negative x minus pi over 6. And this new variable, let's call it z, is going to be between pi over 6 and pi over 4. Let's see what we are going to do with this new variable z here. Now that we are here, we have three terms. From these three terms, for two of them, which are basically the second and third terms here, we replace the value that we have for x plus pi over 6 with a new variable like z. What we are going to do with the first term now? Remember, tan of x equals to cotangent of pi over 2 minus x. So I'm going to use that identity and then write tangent of x plus 2 pi over 3 as cotangent of pi over 2 minus x minus 2 pi over 3. Now it's just a simplification. You will see that at the end we will replace everything with cotangent of negative x minus pi over 6, which is basically the z variable that we define. Altogether, we have cotangent of z. Interestingly, the whole expression now can be replaced with cotangent of z plus tangent of z plus cosine of z. Now what we are going to do with this? Let's see. First of all, we can get derivative, but it's not going to be easy. What else we can do? I'm going to use another identity. Remember, tangent of z plus cotangent of z can be replaced with 2 over sine of 2z. It's very easy to verify that it's correct. You just need to replace tan and cotan based on sine and cosine, and then you will see this here. Now that we have 2 over sine of 2z plus cosine of z, first thing that we need to do is to basically see where 2z is going to be belong. When z belongs to pi over 6 and pi over 4, if we multiply both sides by 2, then 2z is going to be between pi over 3 and pi over 2. Now let's take a look. We have cosine of z and we have sine of 2z. Let's focus on cosine of z for now. Cosine of z, for the range that we are interested, is going to be a decreasing function, always decreasing function. So its maximum is going to be on the initial point that we have inside this range. That's good. What about the first term, which is basically 2 over sine of 2z? For that one, we usually don't do this 2 over sine of 2z. But we already know that sine of 2z is going to have a shape that you are seeing here. For the range that we are interested between this red and the purple one, sine of 2z is going to be always increasing. Obviously, then 2 over sine of 2z is going to be always decreasing, and its maximum is going to be at the initial point in this range. Now we can find the maximum value that this expression can get. Let's do that to find the final answer. Now the first thing that we need to do is to find what value is going to be the minimum value inside these two ranges that we have here. It's easy to verify that it's pi over 6. Then 2z is going to be pi over 3, and sine of 2z is going to be sqrt root of 3 over 2. Cosine of z is going to be cosine of pi over 6, which is basically sqrt root of 3 over 2. And then if you add them together, you will end up with 11 times sqrt root of 3 over 6, and that's our final answer. Thanks for watching the video. If you would like to see more puzzles, maths involved activities, and problems from different math competitions and Olympiads, please subscribe to this channel. This is the SQRT channel, and we will see you in the next video.